Hello children, hope you are all doing good. Children, have you all learned the lessons which I have taught you in the previous classes? Okay, let us write a small test. Okay children, so take your homework note. Put today's date, mention it as test. So the first question, when the velocity of a body changes constantly or uniformly, the body has dash. When the velocity of a body changes constantly or uniformly, the body has dash. Second question, what is meant by retardation? What is meant by retardation? Okay, the options are the velocity of a body increases or the velocity of a body decreases. Okay, what is meant by retardation? Options are the velocity of a body increases and option B, the velocity of a body decreases. Okay children, write the correct answer. Okay, and then the third question, what is the formula to find acceleration? What is the formula to find acceleration? And then fourth question, dash is the rate of change of displacement. Dash is the rate of change of displacement. And then write any two examples of vector quantities. Write any two examples of vector quantities. And the last question, dash is the shortest distance travelled by a moving body. Dash is the shortest distance travelled by a moving body. Children, have you all completed? Okay, very good. Keep your pens down. Let us recall. Okay, children. Children, after writing the test, you should check. Okay, children, you should check your answers. Okay, children. Okay, find the correct answers for your for the questions. Okay, children, for the test, you should find the correct answers. Okay. Then only you can correct yourself. Is it children? So that you should find the correct answers. Okay. So we are learning lesson 2. Is it? The lesson name is motion and force. So what is meant by motion? If a body changes its position, we will set it as motion as the children. And what is meant by rest? If a body does not changes its position, that is called rest. Is it? And then we have learnt about the types of motion. What are the types of motion we have learnt? Translatory motion, rotatory motion, oscillatory motion, vibratory motion, periodic motion, non-periodic motion, multiple motion and random motion. Is it children? And then we have learnt about the simple pendulum. Is it? What are the terms involved in the simple pendulum? Length of the pendulum, amplitude of the pendulum, oscillation, frequency, time period and mean position. Is it children? Okay. And then we have learnt about the factors affecting simple pendulum, factors affecting the time period of the simple pendulum, and the factors does not affect the time period of the simple pendulum. Is it? What are the factors which affect the time period of the simple pendulum? Length of the pendulum. Okay, length. If you are changing the length means it will affect the time. Okay, and then the acceleration due to gravity will also affect the length of the pendulum. Okay, as a time period of the pendulum. Okay, children. And what are the factors which does not affect the time period? Mass of the bob, material of the bob, and also amplitude. Okay, children. And then we have learnt about the two types of quantities. What are the two types of quantities? Scalar quantities and vector quantities. Okay, two types of physical quantities. What are the two types? Scalar quantities and vector quantities. What are scalar quantities? The physical quantity that has only magnitude, okay, which has only magnitude is scalar quantity, and which has both magnitude and direction is called vector quantity. Okay, children. So distance and displacement. Distance is a scalar quantity. Is it, children? So we will mention I had travelled 50 kilometers. Is it, children? That is the scalar quantity. And what is the displacement? I had travelled 25 kilometers in the north. Okay, if you are mentioning the direction also means that is displacement. Okay, so that is a vector quantity. Okay, children. So what is the distance? You are choosing, if you are traveling means you will choose a path. Is it, children? The distance of the path, the length of the path is the distance. Okay, so we can say as actual length of the path. Okay, children. And then what is meant by displacement? You are choosing a path. Is it, children? You are going to a place. Is it? For that there will be a shortcut. Is it, children? That the shortest distance is the displacement. Okay, so we know a displacement is always less than or equal to the distance travelled. Okay, comparing to the distance, the displacement is less. Okay, children. So after that we have learnt about speed and velocity. Is it? What does mean by speed? If you are going by a car means you will say, is it, children? Go, daddy, go fast. Likewise you will say, is it? The calculating the fastness or slowness of a vehicle. Okay, for that we'll mention as speed. Okay, speed means distance travelled by a body. Okay, children. So what is the formula? Distance travelled upon unit time. Okay, distance travelled upon unit time. Okay, children. So speed is a scalar quantity. Okay, and then velocity is a vector quantity. Okay, children. Velocity, speed along with the direction means that is velocity. Okay, 50 kilometer per hour towards north, that is velocity. Okay, children. So what is the formula to find velocity? Displacement upon time taken. Okay, displacement upon time taken. And then in the last class we have learnt about acceleration. The children, what does mean by acceleration? If you are going by a vehicle, okay, if it speeds up or it slows down, or else if it changes the direction means that is called acceleration. Okay, children. Okay, in a constant moving car there will be any acceleration? No, is it, children? If a vehicle speeds up or if it slows down or else if it changes its direction means there we can say that acceleration takes place. Okay, children. So how will you say define acceleration? The rate of change of velocity. Okay, the rate of change of velocity is acceleration. Okay, so what is the formula to find acceleration? Change in velocity upon time. Okay, change in velocity upon time, that is final velocity minus initial velocity upon time. Okay, children. So we have learnt about uniform acceleration, and that is uniform acceleration means positive acceleration, and then negative acceleration, that is retardation or deceleration. So children, so what is meant by the uniform acceleration? When the velocity of a body changes constantly, okay, if it changes constantly means that is uniform acceleration, okay. In the first second, if it moves 40 meter per second, and after 10 in the first, okay, before starting, if it moves 40 meter per second, and after 10 minutes it moves 50, after 20 minutes it moves 60. Likewise, the speed, that is the velocity, increases positively means uniformly means that is uniform acceleration, okay children. And what is the negative acceleration? The velocity decreases, or else if it moves randomly means the velocity decreases not uniformly means that is called negative acceleration or retardation or deceleration, okay children. Can you all understood? So what is the formula for finding acceleration? A equal to v minus u upon t, okay children. Can you all understood? Okay, today in this class we are going to learn about the relationship between uniform acceleration and time, okay. The relationship between uniform acceleration and time. Uniform acceleration we have learned, so children, the velocity of a body changes constantly means that acceleration is called uniform acceleration, okay. So today we are going to learn about the relationship between uniform acceleration and time, okay. Let us see. Children, already we have learnt about displacement, is it? What does mean by displacement? The shortest distance, is it children? So how will you find the displacement? Final position minus initial position, is it children? Final position minus initial position. So we have learnt about velocity, is it? How will you find the velocity? By using this displacement upon time, is it? So we can find the velocity by using this displacement upon time, is it children? So and then how will you find acceleration? Acceleration equal to change in velocity by using this velocity and time taken, okay children. Acceleration equal to change in velocity upon time taken, is it? So we see that all these terms are interrelated, is it children? But what is the nature of the relationship between these terms? Do you know? Initial velocity, final velocity, displacement, time taken, acceleration. What are the relationship between these terms? Do you know how exactly are they interrelated? See, if given some of these terms as displacement, initial velocity, final velocity, okay, how do we find the others? If displacement, initial velocity and final velocity was given, okay, how will you find the others? For that we need a equation, the children. So in order to derive, okay, in order to solve these problems, we derive the equation of motion, okay. So for deriving the equation of motion, okay, let us ignore the first one, displacement, okay children. Leaving that displacement, see all other terms, initial velocity, final velocity, acceleration, time taken. Does any formula arises in your mind? Have you learnt any formula with these terms, initial velocity, final velocity, acceleration and time taken? We have learned, is it children? The formula for acceleration. Acceleration equal to final velocity minus initial velocity upon time taken, is it children? That is A equal to V minus U upon T. Is it children? So by using that we are going to derive a new relationship, okay. There is a relationship between uniform acceleration and time, okay. There is a relation between uniform acceleration and time. What does mean by that uniform acceleration? When the velocity of a body changes constantly or uniformly, then we can say it is an uniform acceleration. So children, if a body changes its motion, its velocity constantly, means that is called uniform acceleration. Is it children? So we are deriving the relationship between uniform acceleration and time. Okay, how can we derive? Do you have any idea? Okay, we are simplifying this equation first. Okay, children. Okay, we are so what is the formula? A equal to V minus U upon T, is it? So we are just cross multiplying. Okay, so we are getting AT equal to V minus U. Okay, we are simply cross multiplying, so that T will goes to the left hand side. So AT equal to V minus U. So this is what we get as a children. And okay, we are going to add U on both sides. Okay, children, we are going to add U on both sides. Okay, what will you get? U plus AT equal to V. Can you all understand? We are just adding U on both sides. Okay, children. So in the right hand side, already a minus U is there. So plus U and minus U are cancelled. So we get U plus AT equal to V. So we can easily get the equation of motion, that is V equal to U plus AT. Can you all understand? We had simply used the formula for acceleration. What is the formula for acceleration? A equal to V minus U upon T. Is it? So first of all we are cross multiplying. So we are getting AT equal to V minus U. And then we are adding U on both sides. Okay, so we will get U plus AT equal to V. Okay, children, can you all understand? So that we got the equation of motion, that is V equal to U plus AT. This is the equation of motion. Okay, children. Yeah, what is the equation of motion? V equal to U plus AT. Okay, children, can you all understand? So what is this U, V, U and AT? Do you know? Let us learn. So V equal to U plus AT is the equation of motion. Is it, children? We have find out. Is it? So that V equal to final velocity. Is it? So and U is the initial velocity. That AT means change in velocity. Is it, children? So see. Final velocity equal to initial velocity plus change in velocity. Okay. V is final velocity, U is initial velocity, and AT is the change in velocity. Okay, children. So for changing that change in velocity, we need acceleration. Okay, what does mean by acceleration? Acceleration equal to change in velocity upon time taken. Is it, children? So final velocity equal to initial velocity plus acceleration into time. Okay, we are just keeping the change in velocity in one side and bringing that acceleration and time taken in another side. So change in velocity equal to acceleration into time taken. Okay, so how you get the equation of motion? Final velocity equal to initial velocity plus acceleration into time. Can you all understood? That V for final velocity, U for initial velocity, and that small a for acceleration and T for time. So that final velocity equal to initial velocity plus acceleration into time. Can you all understand, children? So we know how we had derived the equation of motion. As a children, so what is the equation of motion? V equal to U plus AT. That is final velocity equal to initial velocity plus acceleration into time. Can you all understand, children? So final velocity equal to initial velocity plus acceleration into time. Is it, children? So let us try to understand it with an example. Okay, children. So we have an object, its initial velocity is 10 meter per second. Okay, its initial velocity is 10 meter per second and its acceleration is 1 meter per second square. Okay, and then time equal to 5 seconds. Okay, so its velocity is changing in 1 meter per second for every second. So in 5 seconds, how much velocity is changed in 5 seconds? Okay, how will you find the change in velocity? This acceleration into time. Okay, children. So 1 meter per second upon second into 5 seconds. Okay, so what is the change in velocity? 5 meter per second. Okay, children. So we can find this final velocity very easily, is it? Now we are having initial velocity and we got the change in velocity as 5 meter per second. Is it, children? So if we have add these two means we can easily find the final velocity. Okay, final velocity equal to 10 meter per second plus 5 meter per second. So what is the answer? What is the final velocity? 15 meter per second is the final velocity. Can you all understand, children? The final velocity is 15 meter per second. Okay. So when the acceleration is constant, we can multiply with time. Okay, children, if the acceleration is constant means only we can multiply it with the time. Okay, because of each time period acceleration is the same. Okay, so to get the change in velocity, and first of all we should get the change in velocity and we should add the initial velocity and change in velocity. Then you will get the final velocity very easily. Okay, children, can you all understood? Likewise, we can find, okay, if initial velocity, we want to find that initial velocity means by using this final velocity, acceleration and time, we can find the initial velocity very easily. If we want the time means also, we can find it very easily. Okay, children, can you all understood? So what is the equation of motion? V equal to U plus AT. Okay, how you got this? V means final velocity and U means initial velocity and AT means acceleration and for T time taken. Okay, so this equation of motion is derived from acceleration, final velocity, initial velocity and time taken. Okay, children. So V equal to U plus AT is the equation of motion. Okay. From this we are going to find the relationship between uniform acceleration and time. Is it, children? We are finding the relationship between uniform acceleration and time. Is it, children? So we know the acceleration is uniform. Is it? So we are going to find the average velocity. How will you find the average velocity? Average velocity equal to sum of initial, that means initial and final velocity upon 2. Okay, that is average of initial and final velocities. Okay, children, average velocity equal to V plus U upon 2. Okay, children. So why we have used this? Because we know that the acceleration is uniform, so that we are deriving the average velocity. What is average velocity? Average velocity equal to the average of final and initial velocities. Okay, children. So average velocity equal to V plus U upon 2. Okay. And then we have learned the formula for velocity. The children, what is the formula? Velocity equal to displacement upon time. Okay. From this formula, okay, we are just going to use this formula. Okay. We are going to find the displacement by using this formula. Yeah, how will you find the displacement? If we want to find the displacement means what we can do? displacement equal to velocity into time. Is it, children? So already we are having the average velocity. Is it? We already said the acceleration is uniform acceleration. So that we are taking average velocity. Okay, children. So displacement equal to average velocity into time. Okay, displacement equal to average velocity into time. So displacement, for displacement, yes, is it children? Yes is the symbol. So S equal to, what is the average velocity? See the average velocity, V plus U upon 2, is it? So S equal to V plus U upon 2 into time. Time means small t. Okay, children. So S equal to V plus U upon 2 into t is the second equation. Children, can you all understood? First of all, we have derived the equation of motion, that is V equal to U plus AT. Okay, and then we know the acceleration is uniform, the children, so that we are deriving, we are using the average velocity. So average velocity equal to the average of final and initial velocities, the children. So V plus U upon 2. So we already learned about the formula of velocity, is it? So what is the formula to find velocity? Displacement upon time. Is it? Velocity equal to displacement upon time. From this we are going to find the displacement. Okay, we are going to find the displacement, yes. So how will you find? Okay, we are going to cross multiply. So keep the displacement in the left side and you are just moving the time in the right side. So displacement equal to velocity into time. So already we are having average velocity, so that we are using that average velocity there. So displacement S equal to average velocity into time. So displacement, what is the symbol? Small s. Okay. So average velocity already we have V plus U upon T, is it, children? So S equal to V plus U upon 2 into T. That is the second equation. Can you all understand, children? Okay, this is the relationship between uniform acceleration and time. Can you all understand? We have learned two equations. What are the two equations? V equal to U plus AT, that is the equation of motion. Okay, children. And then displacement, for finding displacement, S equal to V plus U upon 2 into T. Children, can you all understand? Okay, for finding this we have 3 note. Okay, children, we will see that note. Okay, children, just imagine, okay, if you are just throwing a ball, okay, from the top of the roof, okay, what will happen? From the top, if you are holding, means it is at rest, is it, children? So we can say the U equal to 0. Okay, when a body starts from rest, okay, if you are going to throw, means you will just keep it in your hand, is it, children? Before throwing, you will keep it in the hand, is it? So that we are mentioning that initial velocity U equal to 0. That is the first note. Okay, and then, okay, you are throwing the ball from your from the top to the bottom. Okay, it will fall down, so children, it will fall to the ground. Okay, after comes to rest, what will be the final velocity? நீ த்ரோ பண்ணிட்டு அது கீழே வந்துருச்சு, அப்போ what will be the final velocity? It will be 0, is it, children? It is at rest, is it? So when the body comes to rest, the final velocity will be 0. So V equal to 0. Okay, and then if it is moving at constant velocity, means already we have learnt about uniform acceleration, is it, children? So constant velocity means for the first second, if it moves 5 meter, and again in the next second it moves 5 meter, so 10 meter, again in the next second 15 meter. So there is an uniform acceleration, so children, so the acceleration will be also 0. Okay, if the movement is constant, okay, if the velocity is constant means acceleration will be 0. Okay children, what are the 3 notes we have learnt? When a body starts from rest, u equal to 0, that is initial velocity equal to 0. Okay, and when the body comes to rest, the final velocity v equal to 0. Okay, and if it is moving at a constant velocity, acceleration equal to 0. Can you all understand children? Okay, and then the next topic we are going to learn is acceleration due to gravity. Have you heard this word? You have learned, is it children? You have learned in the topic force, is it children? So what is meant by this acceleration due to gravity? Okay, let me explain you. Okay children. Okay, you may have seen the ripened fruit falling to the ground. The children, why it is falling to the ground, do you know? If you are throwing the ball upwards, will it fly in the sky? Will it goes to the sky? No, is it? It will fall to the ground, is it children? What is the reason, do you know? If you are throwing a ball from your terrace to the ground means it will come to the ground, is it? What is the reason? Because of the gravitational force. Okay children, because of that gravitational force on the earth, the objects are coming back to the ground. Okay children, the earth is only having the gravitational force. Okay children, the earth is only having the gravitational force, so that all the objects in the earth are coming to the ground. Okay, so that we are standing erect on the ground. Okay, our houses and all the buildings in the earth are fixed in the ground. Okay, if you are in the space means we'll be floating in the sky. Okay, we will be flying. Okay children, so because of that gravitational force, we are all standing erect. Okay, we are all sitting properly. Okay, in the earth. Okay children, so just try. Okay children, okay, you should try it and find it. Okay children, just keep 2 things. Okay, one is a coin and another one is a feather. Okay, throw these 2 from at the same time you should throw these 2 from the terrace. Okay, just throw these 2 to the ground. Okay, observe that which will come to the ground first. Okay children, in the ancient days they had thought that the heavier objects come to the ground first and the lighter objects will fall later. Likewise they had thought that in the ancient days, in the earlier period. Okay children, but a scientist named Galileo Galilei, okay, tried this experiment from the Leaning Tower of Pisa. Okay, he had tried the same experiment from the top of Leaning Tower of Pisa. Okay, we have learned as a children, Pisa Vinsa in the Cobram. Okay, from that Pisa's Leaning Tower, he had tried this experiment. Okay, he had thrown 2 objects, that is, one is a feather and another one is a coin. Okay, he had thrown. Okay, he had just put it down. Okay, he had observed that the 2 objects, the coin and also the feather, come to the ground at the same time. Okay, which means the time taken to reach the ground would be independent of the mass of the object. Mass enna different irundhalum, time will be same. Okay, a feather means it will be very light. The children, a coin means somewhat thicker than, somewhat heavier than that feather, is it? But if we had thrown the 2 objects at the same time from a terrace, it will come to the ground at the same time. Okay children, can you all understood? So in this gravitational acceleration due to gravity also, we are going to learn that if you are just dropping a stone from the top of the terrace means it will come to the ground. Okay, while falling, okay, first of all, if you are just going to throw it means it will be at rest, the children, so that we can say that initial velocity will be 0. Is it? After coming to the, okay, after taking some distance, the velocity will be increases. Okay, the velocity will be continuously increases. Okay, while throwing from the top of the terrace, its velocity will be low. After coming to the ground, okay, after while reaching to the ground, it got the velocity increases. Okay, increases continuously. Can you all understand, children? So this downward direction, this acceleration in the downward direction is called acceleration due to gravity. Can you all understand, children? If you are throwing an object from the terrace means, first of all, if you are leaving that object from the top means it will have a least velocity. But after moving some distance, it will get the velocity increased. Okay, children, the velocity will be increasing continuously. Okay, in that time there will be a downward force, as a children, that is called the acceleration due to gravity. Can you all understand, children? So the acceleration due to gravity on the earth is 9.8 meter per second square. Okay, the gravitational force on earth, its value is 9.8 meter per second square. Okay, children. Okay, if the object is moving down, okay, if you are throwing it from the terrace, the object is moving down means the acceleration due to gravity is 9.8 meter per second square. Okay, if you are throwing the object from the ground means that acceleration due to gravity will be in the negative state. Okay, so acceleration equal to minus 9.8 meter per second square. Can you all understand, children? Okay, while dropping a stone from the terrace, at the rest it will be at 0. After moving some distance, the velocity will be also increasing continuously. Okay, children, this is just because of the acceleration due to gravity. Okay, the acceleration in the downward direction is called acceleration due to gravity. Okay, children, and then, okay, there is a value 9.8 meter per second square. Okay, if you are throwing an object from the terrace means the acceleration due to gravity's value is 9.8 meter per second square. But if you are throwing a stone from the ground to the sky means it will have the acceleration due to gravity as minus 9.8 meter per second square. So already we have learned the equation of motion formula. The children, what is the formula? V equal to u plus at. Is it, children? So because of that acceleration due to gravity, here the formula becomes V equal to u plus gt. Okay, u equal. So that equation of motion V equal to u plus at becomes V equal to u plus gt. Okay, children. Okay, first of all, if you are throwing a ball from a terrace, okay, it will fall from the height, the children, so that the equation becomes V equal to u plus gt. Okay, you are changing that acceleration to acceleration due to gravity, so that V equal to u plus gt. Okay, and again, if you are throwing it from the ground to the upward direction means ground to the sky means that formula becomes V equal to U minus gt. Can you all understand, children? So if the body is freely falling from a height, means V equal to U plus gt, and if it is thrown upward direction, means that is V equal to U minus gt. Can you all understand, children? So in this class we have learnt about the relationship between uniform acceleration and time. Is it what is meant by the relationship? What are the relationship we have learnt? What are the equations we have learnt? First of all, V equal to U plus AT, and the next is S equal to V plus U upon 2 into T. Okay, and then we have learnt about acceleration due to gravity. Is it? What is meant by that acceleration due to gravity? The acceleration in the downward direction is called acceleration due to gravity. Okay, if it falls freely, means the velocity will be continuously increasing. Okay, so the acceleration in the downward direction is called acceleration due to gravity. Okay, what is the value we have learnt? 9.8 meter per second. Okay, children, 9.8 meter per second squared, or 980 centimeter per second squared. Okay, children, 9.8 meter per second squared. Okay, memorize this. Okay, children, what is the value for acceleration due to gravity? 9.8 meter per second. Okay, this is on earth. Okay, the gravitational the acceleration due to gravity on earth. Okay, its value is 9.8 meter per second squared. So if a body falls freely from the height, means what is the formula? V equal to U plus gt. Okay, if it is thrown upward, that is from the ground, means what is the formula? V equal to U minus gt. Can you all understand, children? So, and then we have learnt about a scientist, the children, the experiment of a scientist. What is his name? Galileo Galilei. Okay, he had done an experiment with a coin and a stone. Okay, that is of different masses. So what he find out? The time taken is independent. Okay, time taken to reach the ground is independent of the masses. Okay, children, the time taken to reach the ground is independent of the masses. Okay, so we have completed this lesson. Okay, children, yeah, take your classwork note. Yeah, first of all, we will check the yesterday's homework. Okay, the first question, have you all taken? Acceleration is defined as rate of change of velocity. Okay, the first question answer is rate of change of velocity. And then second question, meter per second squared. The SI unit of acceleration is meter per second squared. Okay, and then third question, a negative acceleration means the velocity of a body decreases. Okay, decreases. And then fourth question, which is a vector quantity? Acceleration is a vector quantity. Okay, children. And then fifth one, we know the unit is meter per second squared. The children, so 40 meter per second squared is the answer. Okay, children. So the sixth one, the rate that a car velocity changes is its acceleration. Okay, the rate of change of velocity is acceleration. The children, so the rate that a car's velocity changes is its acceleration. So check your answers, children. If you got anything mistake, means correct your answers, children. And then put. Children, already we have written 6 problem questions in your notebook. Is it, children? This is the 7th one. Okay. Yeah, read the question. Find the initial velocity of a car which is stopped in 10 seconds by applying brakes. Okay, the car is stopped, the children. So the final velocity v equal to 0. Okay, so the time taken is 10 seconds. Okay, children. And retardation, what does mean by retardation? Negative acceleration. The children, retardation due to brakes is 2.5 meter per second square. So it is negative acceleration. So acceleration equal to minus 2.5 meter per second square. So let us write the given equal to, given A equal, there is acceleration equal to minus 2.5 meter per second square. The children, that is negative acceleration. The children, so that we are including a minus there. Okay, minus 2.5 meter per second square. Okay, so they are given the time, that is 10 seconds. Okay, and they said the car is stopped. The children, by applying brakes, the car is stopped. So the final velocity v equal to 0. So we are going to find the initial velocity. How will you find? How will you find, children? Does any formula arises in your mind? By using acceleration, time taken, final velocity, how will you find the initial velocity? We can use the equation of motion. So children, v equal to u plus at. Is it? V equal to u plus at. By applying all the values in this equation, we can find very easily. So children, so v equal to 0, u, we are going to find the initial velocity u, is it? And then acceleration is given 2.5, is it, children? So 2.5 into 10. So we can substitute all the values in this equation. Okay, children. So v equal to 0, put the same u, and again minus 2.5 into 10. Okay, minus 2.5 into 10 means, what will you get? 25.0, is it, children? So 0 equal to u minus 25. Okay. So we are going to find the value for u, is it, children? So you should change the terms. Okay, so u equal to 25 meter per second. Can you all understand, children? Okay, we are just using the equation of motion. In that equation of motion, you are substituting all the values and we can find very easily. Is it, children? Yeah, you can write. Write it fast. Children, use only ink pens, okay? Children, have you all completed? Let us see the next problem, okay? See the next problem. A stone dropped from a tower reaches the ground in 5 seconds, okay? The stone is dropped from the tower. So, we can say the initial velocity is 0. So, children, throw panna pora appanna First of all, it will be in the initial position is 0, the children. So initial velocity u equal to 0. So the time is 5 seconds. Okay, children. And then calculate the velocity with which it will hit the ground. Okay, we are going to find the velocity, and g value is also given. U equal to 0, time is 5 seconds, and g equal to 9.8 meter per second squared. Okay, so given u equal to 0, time equal to 5 seconds, and g equal to 9.8 meter per second squared. Okay, so how will you find the velocity? What is the formula? We can substitute in the acceleration due to gravity formula, is it, children? So it is falling freely, is it, children? It is falling from the top to bottom, is it? So what is the equation? V equal to u plus gt. Okay, V equal to u plus gt. By applying in this equation, we can find the velocity very easily, is it? So we can apply all the values here. So u is given, so v equal to 0 plus g is 9.8 into 5. Okay, so multiply 9.8 into 5. Multiply and say the answers, children. 9.8 into 5. So the velocity is 49 meter per second. Okay, children, have you all got this? Very easy, the children. Okay, they had already said the stone is dropped from a tower, so that it is freely falling, is it, children? So that we should use the acceleration due to gravity formula, is it? So if it is freely falling means the initial velocity will be 0, is it, children? We have learnt in the note, is it? So the initial velocity will be 0, so u equal to 0, time is given, and also gravity is given. So we can easily substitute in the acceleration due to gravity equation, is it, children? So v equal to u plus gt. Okay, substitute all the values. Okay, by substituting we can find the velocity very easily. What is the velocity? 49 meter per second. Okay, children, you have copied down in your notebook? Children, can you all understood? We have learned the note, is it, children? What is that note? When a body starts from rest, its initial velocity is 0. Okay, that is u equal to 0. Okay, if it is starting from rest, okay, rest length start agapodhu appadina, the initial velocity will be 0. Okay, and then if it is coming to rest means the final velocity will be 0. In the first sum, it is stopped, is it, children? Because of applying brakes, it has stopped. Okay, so that the final velocity is 0 there. Okay, here it is freely falling, is it, children? We are throwing that stone from the top of the tower, is it? Before throwing, it will be at the rest, is it, children? So that the initial velocity u equal to 0. Children, can you all understood what I am saying? Okay, you should read that note. Okay, if you had any doubt means you should read that note. It is in page number 26. Okay, 26 and 27. There are 3 notes. When a body starts from rest, initial velocity u equal to 0. Okay, and then B, when the body comes to rest, its final velocity v equal to 0. Okay, and if it is moving at constant velocity, the acceleration is 0. Okay, children, remember these notes. Okay, then only you can do these all problems. Children, have you all completed this problem? So the next question. Children, this is your homework. Okay, the first question is the acceleration of objects falling on earth due to gravity. Okay, its value is dash. Okay, and then second one, when a body comes to rest, its final velocity is. Okay, it is from note. Okay, children. And then third one, dash is the equation of motion. Okay, write that. Okay, children. And then fourth question, when a body is thrown upward, what is that? What is that equation? Write that equation. Okay, v equal to dash. When a body is thrown upward, v equal to dash. Okay, how will the equation change? You should write that equation. Okay, children. And then see page number 30. There is 5 fill in the blanks. Is it, children? Okay, that 5 fill in the blanks is your homework. Okay, tomorrow we will complete, okay, all the book activity and also the worked out examples. Okay, children, there is some problems in the worked out examples. Is it? Okay, try to learn it and I will explain you in the next class. Okay, children, thank you.